Hi everyone, I'm Chen Xiyan. Today I will be presenting my study, The Effect of Fatigue Loading on Impact Mechanics and Bone Composition of Rodent Ulnae. Our bone regulates its health through remodeling process, which can be affected by both external and internal stimuli. The remodeling process will affect both bone structure and the physiochemical composition by removing matured bone and depositing new bone at a certain rate. Remodeling can affect the arrangement of collagen fibers and mineral crystals, as well as changing the amount of organic and mineral content. However, a stress fracture could occur when bone experiences repetitive loading over a certain threshold and the damage accumulated exceeds the rate that the remodeling process can repair. Previous studies have provided some insights on how the remodeling process would affect the mineralization level of the bone, and the researchers have used the animal models with bending tests to measure the change in the mechanical properties and their relationship with physiochemical composition. However, much less was investigated on a rapid dynamic loading condition such as impact. In our study, we used 22 rats and all their right forelimbs underwent cyclic fatigue loading, and 11 rats were sacrificed within 24 hours after the loading, and the remaining were sacrificed after 7 days rest. And then micro-CT imaging and mechanical testing were performed. We also collected 24 section bone samples for the FTIR analysis of the physiochemical composition at different regions. In the FTIR analysis, we can find the peak of each main chemical component. In this case, we found the peak for the carbonate, phosphate, and the Mi1. When we are able to calculate the intensity of each component by calculating the area under the curve. And as a result, we can obtain the carbonate to phosphate ratio, indicating the level of substitution of carbonate into mineral crystals, and also the phosphate to Mi1 ratio, indicating the ratio of mineral content to the organic content. The CT image showed that in 1-day rest group, there is no noticeable difference in the structure. However, the loaded ulna had reduced stiffness under the impact. And in the 7-day rest group, the CT image showed that the loaded ulna had a formation of woven bone on the periosteal side of the bone, and also the loaded ulna have still reduced stiffness under the impact. Besides the change in the structure and mechanical properties, we wonder if there's any change in the chemical composition. So the FTIR results reveals that the woven bone region had slightly reduced carbonate level, similar level of phosphate, and significantly reduced level of Mi1 compared to other cortical regions. And as a result, the woven bone region has increased phosphate to Mi1 ratio and a slightly decreased carbonate to phosphate ratio. Our study indicates that 7-day rest does not provide sufficient rest time for bone to fully recover from fatigue damage, and also the chemical composition changed in the region where the remodeling process was most active, in our case, on the periosteal side. Besides, the increase in mineral to matrix ratio did not guarantee the increase in mineral content nor the stiffness. Our study can potentially provide insights on prevention and treatment of stress fracture in athletes and military personnel, as those groups are two groups that are most susceptible to stress fracture. I would like to thank my founding source and my lab member for the support of this experiment. Thank you.